Universal. Why should such a set of universal principles exist? Why should we assume that the principles governing human intelligence, consciousness, language, and self-recognition are the same principles that govern sensory organs, protein receptors, and genetics? Why should we assume that the principles governing all biological phenomena are universal? This same question can be asked about the laws of motion in physics. Why do we assume that all objects in this universe, in regard to their motion, obey a single set of physical laws without exception? Why should the principles governing the motion of a race car on Earth be the same as those governing the orbit of Pluto or a binary star system 100 light-years away? Why do we assume the laws of physics are universal? Historically, physicists assumed a single universal set of physical laws was due to experimentation. Scientists working with weights, springs, pendulums, and similar objects observed patterns in their behavior, eventually formalizing these patterns into a theory capable of making predictions, such as determining where a cannonball will land given certain initial conditions. This theory of motion was then applied to various objects and found to be predictively accurate through continued experimentation. From thermodynamics to the movement of celestial bodies, to the refraction of light through lenses, the laws of motion have proven generally applicable across many domains of study, explaining such a wide range of physical phenomena that they are assumed to be universal. The same can be said about all biological phenomena. By understanding precisely what a pattern is, it will be shown that a universal set of principles exists to be found. This does not imply that there are no intermediate theories or principles governing only human intelligence or only genetic evolution. A theory of human intelligence may be distinct from a theory of genetic evolution, but the assumption of universality implies that a deeper, more fundamental set of principles governs both, as well as all other biological phenomena, including science and manufacturing. This set of principles, which has not yet been found or described, must be found and described, for it is the very foundation upon which all else is built. Philosophically, we can argue for the universality of such a theory based on the fact that all phenomena exist within a single physical reality. If all biological phenomena exist within the same physical reality and are fundamentally governed by the same set of physical laws applied uniformly across all, it follows that all biological phenomena would also be governed by a shared set of biological principles. The alternative would be a universe divided into partitions, where the ultimate laws of reality differ in various places and apply unequally. But we do not need to go that far to argue for the universality of a complete theory of intelligence. As far as we are concerned, all the laws of physics apply equally on Earth, and as far as we have observed, all biological phenomena have been found on Earth. We can argue that, at the very least, universality is locally true. We do not need to accept the argument of a single universe with universal laws to acknowledge the existence of a single set of principles governing both biological and intelligent phenomena. We can argue for universality based on practicality. There are two major practical reasons to accept and proceed as though universality is true. The first reason is simplicity. Denying universality would force us to create multiple theories to explain different phenomena. Cannonballs fired in Europe would have different trajectories than those fired in America. There would be different theories of motion in physics. There would be a theory of genetics that applies only to genetics, a theory of neurons that applies only to neurons, and a theory of camouflage that applies only to specific species. Not only would each theory be distinct, but there would also be no shared commonality or overlap. No general solutions linking phenomena to one another. And why not divide it even further? Why not have a theory that applies only to one location at one specific time? A theory that works in New York would not work in Houston, and a theory that applies in 2020 would not work in 2025. Denying universality leads to a proliferation of theories we must memorize and constantly keep track of. The second reason is engineering. We want to build and create with our theory. Denying universality would render all engineering pointless. There would be no reason to expect the wings of birds and the wings of airplanes to work in a similar manner. We would expect no similarities between the fins of penguins, sharks, and whales, or even between two individuals of the same species. We would not be inspired to build camera systems by observing how biological eyes work. No biomimicry in robotics. Nor would there be any point in pursuing artificial intelligence or reproducing human intelligence, because if we deny universality, There is no reason to expect systems that work in a biological substrate to be transferable to silicon transistors. No reason to believe evolutionary algorithms would work. No reason to expect neural networks to function. But the fact is that it does work. The wings of birds operate in a similar manner to the wings of airplanes. The fins of penguins, sharks, and whales share similar shapes. Recent advances in artificial intelligence, especially in machine learning and the development of neural networks, were inspired by human neurons. Given the existence of so many general solutions transferable across diverse mediums, we expect there to be a universal set of underlying principles, a set of universal underlying principles that must be found and described at all costs.